All right, on number 5, it says to differentiate implicitly. So let's write out number 5 first. So number 5 says find the slope of the graph at that specific point. So we need to find at 1 comma negative 2 that we're going to plug in after we differentiate it implicitly. Then we have negative 2 over x cubed is equal to y. Now, before I do anything, let's go ahead and make this friendlier. Let's bring this to the numerator. So I have y is equal to negative 2x to the negative third. So now let's find the derivative. If I find the derivative of this, what do I do with the power and the coefficient? We multiply and we get how many? 6. And it's 1 less the power is how many? Negative 4. And now I need to figure out what's going to happen when I plug in the values. Here's my x. And is there a y piece by itself that I need to plug in here?
No.
So just the x. So I'm going to put in our y prime is our slope function, 6 times the 1 to the negative 4. And because I have an even number as my power, is that 1 going to change?
No.
Nope, just 6. So it says to find the slope. The slope at 1 comma negative 2 is equal to 6. And that is it. The next one is number 9. Are we ready for number 9? Not yet. I'll wait a little bit. Y'all be nice, I'm recording. Both of you guys. Me. Okay, while I'm waiting, I'm going to write number 9. So number 9, I want to rewrite this so we have a power rule. So we have y is equal to, let's go ahead and leave this in parentheses, x cubed minus 1. And then the root becomes the denominator of my power. So in this case, it's 2/3. All right. So we have to use what rule on this one? Chain rule. We have a function within a function. So normally I would multiply by the number out here. Since we don't have any, you could write the 1 if you want. So we get y prime is equal to, when I bring that down, we get 2/3. Do I do anything with the inside at first?
No.
You leave it alone. And if I take 1 less from 2/3, how many would that give us? Negative 1/3. And if you're still having trouble subtracting and adding 1 with the fraction, come in for tutoring. And in the inside, what is the derivative of the inside? 3x squared. And done. That's it. I know, you guys are looking at problems going, whoa, that looks hard. All right, 15 is our next one. Where's my number 15? Here it is. Oh, we got some reading. Luke, let's read.
We're doing 15.
15.
Find the equation of the tangent line at 3 negative 6 for x plus 3 squared plus y minus 2 squared is equal to 100.
That was 15, right?
Yes, sir.
Okay. So on number 15, we're looking for the slope at the following point of 3 negative 6. And we do have to find the derivative of x plus 3 all squared. Are we going to use the chain rule again? Yep. Plus y minus 2 all squared is equal to 100. Can anyone guess what the radius of this circle equation is? If you think about conics from last year. What is 100 squared? I mean, square root of 100. 10 is the radius. If you're like, what? So if you're taking that SAT or ACT, that might be useful. Okay, let's move on. Let's go ahead and find the derivative. Maybe a different color will be nice with respect to x. So when I find the derivative and we have a chain rule, 2 is going to come down. Am I going to mess with the inside? Nope. And 1 less of the 2 is understood 1. And I know the next piece we might not really need because derivative of 1x is simply 1. So if you're like, hey, I don't want that 1, don't write it. The next piece, here's our chain rule again. We have 2, keep the inside, 1 less. And yes, you can go ahead and write out the 1 at the end. But anything I do with the non-x's, what do I need? dy over dx. And what's the derivative of any constant? 0. Yes, ma'am.
Wait, why did you put times 1 after the first one?
Derivative of 1x is 1. And that's why I was saying if you don't want to write it, don't. All right, let's go ahead and make dy over dx by itself. And I'm going to do 2 things. So listen carefully. The first thing that I'm going to do is subtract this on both sides. So I'm going to subtract it on both sides. The second thing that I'm going to do is divide it by this guy on the bottom. So I'm going to do one go. dy over dx is equal to, when I move this over, I need minus 2 of that value. And notice I'm not simplifying as I'm going because you don't have to. Divided by the coefficient right next to the dy over dx. And at this point, all we need to do is plug in 3 for the x, negative 6 for the y. This is our slope function. Now I'm going to keep writing this out because it's been a while. Maybe some of you guys forgot. So my slope function for this one is negative 2. My x is represented by 3. And copy everybody as I have. My y is negative 6 minus 2. And if I do my tedious math from here, we get negative 2 times 6. The bottom is 2 times negative 8. Don't we know the 2's are going to cancel anyways? You can multiply it out if you want, but you don't have to. Right, Grant? Was on the computer the whole time? So we get 2 negatives, 3 over 4. So our equation is going to be point slope formula. So we have y minus y1 is equal to m times x minus x1.
Oh, is that the m?
And this is our m, which is our slope. So we have y minus a negative 6 is going to give us positive 6. Our slope is 3/4, and x minus a 3, and you do not have to simplify it further.